What was there before the Big Bang? This question has boggled the minds of scientists and philosophers alike. In the quest to understand the universe, this is one of the most perplexing questions we face. The traditional understanding of the Big Bang is that it's the starting point of the universe, the moment when everything we know came into existence. It's like the first note in a symphony, the point from which all the music flows. But what about the silence before the first note? If we think of the Big Bang as the beginning of everything, it's natural to wonder what existed before it. But here's where we hit a roadblock. Our understanding of time and space, the very framework we use to make sense of the universe, originates from the Big Bang itself. It's like trying to look at a painting when you're standing on the canvas. Imagine, for a moment, that we're able to step off that canvas and view the painting from a distance. We'd probably see a vast, complex picture filled with colors and shapes we couldn't comprehend while we were standing on it. That's what we're dealing with when we ask what was there before the Big Bang. The Big Bang didn't just give birth to matter and energy, but to time and space as well. This means that the concept of before might not even exist in the context of the Big Bang. It's like asking what's north of the North Pole. The question itself assumes a condition, the existence of time before the Big Bang, that might not apply. This is why this question is so difficult to answer. Our understanding of the universe is rooted in concepts that came into existence with the Big Bang itself. So, when we try to look beyond that point, we're stepping into uncharted territory, a realm where our conventional understanding of time and space may no longer apply. So, if the Big Bang is the start of space and time as we know it, how can we even talk about before it? One of the theories that have attempted to answer this question is the theory of cosmic singularity. Envision, if you will, the entirety of the cosmos. Every star, every galaxy, every iota of matter and energy, all condensed into a single point. A point so dense, so incredibly compact that it's virtually impossible to comprehend. This is the concept of the cosmic singularity, a theory that suggests before the Big Bang the universe was this singularity, a point of infinite density. This theory is a bit like trying to fit all the water in the world into a single glass. It's a mind-bending concept, isn't it? And it's one that's based on the laws of physics as we currently understand them. According to these laws, as we trace the universe's expansion back in time, everything begins to converge, eventually leading us to this single, infinitely dense point. But here's the catch. The cosmic singularity theory has its limitations. It's based on the laws of physics as we know them to be true in our current universe. However, these laws may not apply when we're dealing with conditions that existed in the pre-Big Bang universe. It's akin to trying to apply the rules of chess to a game of poker. They're both games, but the rules are vastly different. So, while the cosmic singularity theory does provide an intriguing concept, it's also a bit like looking at the universe through a keyhole. It gives us a glimpse, a tantalizing peek into what might have been, but it doesn't show us the whole picture. We're left with more questions than answers. What caused the singularity to expand and become the universe we know? What governed the laws of physics within this singularity? And the biggest question of all, what was there before the singularity? While the cosmic singularity provides an intriguing concept, it also raises more questions than it answers. And as we delve deeper into these questions, we find ourselves spiraling into other theories that attempt to unravel the mysteries of the pre-Big Bang universe. But that's a story for another scene. Another theory that has gained traction among scientists is the multiverse theory. This theory paints an incredibly vast picture of reality, suggesting that our universe, the one we live, breathe, and exist in, is just one among an infinite number of universes. Yes, you heard it right. Infinite. Just as there are countless grains of sand on a beach, so too might there be countless universes scattered across an unimaginable expanse of cosmic landscape. In this grand spectacle, our universe, with all its galaxies, stars, planets, and life as we know it, might just be a tiny speck in a much larger cosmos. It is as if we are living in a cosmic bubble bath, where each bubble represents a universe, and this bath is ever expanding, ever evolving, adding new bubbles as it grows. Now you might ask, where does the Big Bang fit into this picture? Well, in the context of the multiverse theory, the Big Bang could simply be the result of a collision between two of these universes. Imagine two soap bubbles colliding in a bubble bath, the impact causing a massive release of energy, creating a new bubble in the process. That's one way to think of the Big Bang in the multiverse context. Alternatively, the Big Bang could be seen as the formation of a new universe in this cosmic landscape. Just as a new bubble forms in a bubble bath, a new universe might form in the multiverse, its birth heralded by a Big Bang. So, the multiverse theory provides a radically different perspective on the origins of our universe, one that goes beyond the confines of the Big Bang. It gives us a glimpse into the infinite possibilities of the cosmos, stretching our imaginations to their limits. However, as fascinating as this theory might be, it is important to remember that it remains largely unproven. It's a compelling concept, but one that is currently beyond our ability to test or confirm. The multiverse theory gives us a glimpse into the infinite possibilities of the cosmos, but it also remains largely unproven. Quantum physics has also offered its own explanations, such as quantum fluctuations and the no-boundary proposal. Now let's delve deep into these intriguing concepts. First, we have quantum fluctuations, a phenomenon that seems to defy logic and yet is a cornerstone of quantum mechanics. Imagine the universe as a vast, empty vacuum. You might think that empty means nothingness, but in the quantum world, empty is brimming with activity. This activity involves particles and antiparticles popping into existence and annihilating each other in a blink of an eye. These are the quantum fluctuations. Now picture one such fluctuation that didn't annihilate, but instead ballooned into a universe. A wild idea, isn't it? But in the realm of quantum physics, such an event could have been the spark that ignited the Big Bang and birthed our universe. Next, we move on to the no-boundary proposal, a concept that bends the mind as much as it does our understanding of the universe. Proposed by physicists James Hartle and Stephen Hawking, this theory suggests that the universe is finite but has no boundaries. Picture a globe. You can travel in any direction, but you'll never stumble upon a boundary or an edge. Similarly, our universe could be a four-dimensional version of this globe, with no discernible boundaries. Now, let's add another twist. Time, as we understand it, did not exist before the Big Bang. Instead, what we perceive as time emerged along with the universe itself. The no-boundary proposal suggests that before the Big Bang is a nonsensical concept, as there was no before in the absence of time. So here we are exploring the quantum wilderness where universes can spring from vacuums and time is born from a cosmic explosion. These quantum theories provide fascinating perspectives, but they also challenge our understanding of reality. As we journey through these theories, they push us to rethink and reshape our perceptions of the cosmos and our place within it. These quantum theories provide fascinating perspectives, but they also challenge our understanding of reality. So, what was there before the Big Bang? We have explored a few theories that attempt to answer this question. Let's take a moment to recap. We started with the cosmic singularity, a theoretical point of infinite density which may have existed before the Big Bang. Some believe this singularity was the birthplace of our universe, while others argue it may have marked the end of a previous universe. However, the singularity concept is still a subject of intense debate and research within the scientific community. Next, we delved into the multiverse theory, which suggests the possibility of an infinite number of universes existing parallel to our own. This theory posits that each universe might have its own unique set of physical laws, and our universe, with its specific conditions suitable for life, is just one among countless others. Yet, verifying the existence of these other universes remains a challenge due to our current technological limitations. We then explored quantum fluctuations and the no-boundary proposal. Quantum fluctuations suggest that the universe could have originated from a vacuum fluctuation, a temporary change in the amount of energy in a point in space. On the other hand, the no-boundary proposal, put forth by Stephen Hawking and James Hartle, proposes that time didn't exist before the Big Bang, and hence the concept of before is pointless. It's like asking what's north of the North Pole. These theories, while fascinating, are not without their controversies. Each one opens up a new set of questions and challenges to our understanding of the universe. Researchers are continually testing and refining these theories, seeking evidence that might tip the scales in favor of one over the others. While we may not have a definitive answer yet, it is the pursuit of these questions that drives our understanding of the universe ever forward.